this video clip, we will examine information architecture. Enterprise architecture deals with the issues of standardization of business processes, uniform and compatible databases, and integration and information exchange between applications. To support global operations and growth opportunities, designers of enterprise architecture must pay attention to ease of use, flexibility, agility, and security. Organizations typically design their architecture to be aligned with their business model. The most common architectures are centralized and decentralized. A company that manages centrally with uniform operations and procedures everywhere will most likely benefit from a centralized architecture. A centralized architecture is based on a large computer installation that provides all the processing and supports display terminals in every office and branch. Many banks and financial organizations use this architecture. A decentralized architecture, on the other hand, moves some of the business process to local servers and even to users' devices. In this architecture, computers exchange information and provide services as needed. A hierarchy between the computers involved in the business process is called client-server architecture, since it designates some computers as servers and others as clients. When there is no hierarchy, the collaboration is considered as peer-to-peer architecture. Many retail chains prefer the decentralized architecture of client-server. It lets them customize service at the store level and keep the stores open even if the main server is down or disconnected. Peer-to-peer architecture is more popular with music sharing and internet communication services. In recent years, a design concept called Service-Oriented Architecture, or SOA, has been used for application development. SOA focuses on business functionality called service and fast implementation of business processes using a library of pre-built and interoperable services. You may think about it as building a structure using standard Lego blocks. This configuration provides flexibility and enables their business to adapt to changes in the business environment. As the organization translates its information architecture requirements to specific infrastructure components, it is important to consider some of the newer concepts for allocating, managing, and paying for information resources, namely virtualization, utility computing, and the cloud. The use of software to create a device that does not exist in the real world is called virtualization. This means, for example, that rather than purchasing a large capacity device, an organization can use virtualization to define the large capacity device by combining multiple smaller devices. Similarly, it can define multiple small devices carved from a large resource. Think about a large hall in a convention center. It can be used as a large room, or it can be divided into multiple small rooms. In other words, the room can be utilized in several ways depending on the needs of the organization in a specific time. In the same manner, virtualization enables the organization to allocate and utilize its computing resources according to its needs. For example, when virtualization is used to define multiple small servers on a single computer, the organization can buy a single computer and save hardware, maintenance, and operation costs while providing each department with a dedicated computing resource. Furthermore, with some flexibility, the business can change the size and power of each virtual computer as needed. The payroll department will be happy to get all the available power when processing paychecks and has no problem giving power away when done. Virtualization can also define a large capacity device by binding together multiple small devices, an opportunity to overcome physical limitations or to lower costs. No computer is powerful enough to process all of Google's searches. However, with the help of virtualization and other techniques, Google is able to answer most searches in a fraction of a second. The idea behind utility computing, which is also referred to as on-demand computing or software as a service, is that instead of buying and installing expensive resources, such as a packaged enterprise application, the organization rents the application from a vendor. One of the leading vendors in this space is Salesforce.com. It provides organizations a CRM application which they do not need to buy or maintain, but rather pay for actual usage. This is similar to the way organizations use and pay for utilities such as electricity and water. Another way to explain this concept is the use of taxi service as an alternative to car ownership. When you use a taxi, you pay for the ride. You pay more for a longer ride or limo service, but you pay for the ride and the ride only. All other expenses fall on the cab owner. This brings us to the concept of cloud computing. Cloud is a metaphor for the internet, and it is an abstraction for the complex infrastructure it conceals. Cloud computing means that IT-related capabilities are provided as a service, allowing users to access technology-enabled services from the internet without knowledge of or control over technology infrastructure that supports them. Companies that provide cloud services such as Google and Amazon use virtualization to define a virtual server at the size that the customer needs. This server is connected to the internet or is in the cloud and can be reconfigured and resized on demand as needed. As a consequence, cloud computing offers some business advantages such as enabling fast and easy scale of the resources and eliminating the need for building, operating, and maintaining resources. To summarize, technological advances and innovative business models created an alternative to the traditional model of building, allocating, managing, and paying for information resources. Information resources are now in the cloud and are available as services. Thank you.